Okay, so put your hands up if you've ever heard of the word slope before. Let the record show. Everyone's hand is up. Okay, good. What is it? Okay, I've heard of rise over. Let's get all your thoughts down here. So we're talking about rise. I've heard this, rise over run. What does that mean, rise over run? So rise is kind of up and down, and run is left and right, side to side. Okay, I like that. What else do you know about slope? What's the letter we use to actually, M, right? Go figure. We use the little M. And M is equal to all this stuff, the rise over the run. Who's ever heard that's the same thing as the change in Y over change in X? Has anyone ever heard that before? Yes. Okay. What do I mean by change in Y over change in X? How much Y is changing divided by how much X is changing? Okay, so let's do this. Does anyone remember the actual slope formula? Y. Yeah. Okay, you guys are spitting out something that sounds very familiar. Where does that come from? Points. Okay, good. So let's do this. I'll give you a generic x1 point. Easy? Fair enough? I'll give you a generic x2 point. Easy? Fair enough? Okay. So if I go up to this and I go over to this, let's call this point y1. And if I go up to the function here and I go over to this point over here, let's call this y2. Alright, so the slope formula, you guys are telling me that it's something y2 minus y1 over x2 minus x1. So this stuff right here, right? Well, it's those two highlighted parts of the x and y axis, right? That blue part there represents the difference in x values. And that yellow part represents the difference in the y values. So it's just like you guys are saying. It's actually y2, I'll move over a little bit, minus y1 over x2 minus x1. So this is the yellow part, the y2 minus y1. That's that change in y. It's the high value minus the low value, right? The same thing for the x. It's the far value minus the near value. Okay, so change in y over change in x. I also want you to think about slope as a rate of change. Okay, I want you to consider it as a rate of change, basically saying how two things are related, how one is changing in terms of the other. Can slope be positive? Yes. Can slope be negative? Yeah, it can be negative. Can slope be 0? Yes, it can. Can slope be undefined? Yes, it can be all four of those things, okay? Slope is allowed to be positive. Slope is allowed to be negative. Slope is allowed to be the number 0, and slope is allowed to be undefined. We can have all of these different versions of slope. This particular example, this red line that you see, which one of those four is this one? How do you know it's positive? Because it's rising. What does that mean, it's rising? I need more specific. It's going in a vertical direction. How do you know this is positive? There you go. That's it. How do you read a book, you guys? Left to right. So we read a graph the same way. So from left to right, the line is going up. Therefore, positive. What would negative slope look like? Left to right. We always go left to right. Left to right, it'd be going what? Down. Okay, there you go. All right, Okay, I've given you a quick little sketch. I've given you 2 points on the line, and we'll call my line L right there. There's my line L. I have 2 points on the line. Name the 2 points on the line. What are they? 1, 5, and 7, 9. Awesome, good. What is the slope of line L? Well, this is my x1, and this is my y1. This is my x2, and this is my y2. My first set of xy, my second set of xy, right? So according to our little formula, it's going to be y2 minus y1, which is going to be 9 minus 5, all over 7 minus 1. Okay, don't mess that part up, right? All right, so 9 minus 5, how much is that? 4 over 7 minus 1, what would that be? 6. So what's our slope? 2/3. Is this a positive 2/3 or negative 2/3? Positive. Why is it positive? Going up from... There you go. Okay, let's take a look at that pink line right there. There's that pink line, okay? Give me 2 points on that pink line. Anybody? Yell them out. What do you ever got? 0, 3. I love it. Let's do 0, 3. Give me another point that's on that line. 2 comma 3. Okay, let's go with that. 2 comma 3. Let's compute the slope given those 2 points, right? So the slope is going to be, let's see here, y2 minus y1 over x2 minus x1. Sweet. Hey, which one's which? Does it matter? No, I'll just call this x and y my first pair. I'll call this x and y my second pair. Easy enough, right? Okay, y2, what's that going to be? 3. What's y1 going to be? 3 all over what 2 minus 0. What does this give me? Yeah, 0 over 2. What does that give me, everybody? Try again. 0. 0 divided by anything is 0. Okay, so this has a slope of 0. The reason this has a slope of 0 is because there is no change in what direction? There's no change in what direction? The rise. This line does not rise nor fall. This line, thank God, or thank goodness, we have slopes of 0. Why? Because the floor is level. Oh my gosh, imagine if the floor had a slope of 2. We'd all be leaning to one side of the room, right? So slopes of 0 are very good. We love those. That's totally fine. This is in stark contrast to the line I'm about to draw for you right now. This green line. Oh, we're getting there. That's next in the lesson. But that's a great question. Okay, see that green line, you guys? All right, somebody give me any point on that green line. -4, 3. Awesome, at that point. -4, comma 3. Give me another point on that green line. -4, 0. I love it. -4 and 0. Good, let's compute the slope of the green line. Well, it's going to be y2 minus y1 over x2 minus x1. Okay, it doesn't matter, so I'll go x and y my first pair, and I'll go x and y my second pair. Okay, y2, what's it going to be? 0 minus 3, all divided by -4 minus a -4. Okay, what's 0 minus 3? -3. What is -4 plus 4? 0. Okay, someone interpret that for me. That is undefined. We are not allowed to divide by 0. You can't balance on a ball, right? Here, Miss May, did that? Balance on a ball? Okay, so vertical lines up and down are undefined. And the reason is because there's no change in the x direction. There's no change in the x direction. We're not moving left to right. Yeah. So these are special kinds of slopes, right? Vertical lines are lines that go up and down. They have slopes of 0. Horizontal lines, which is the pink line. Wait, sorry, I said that backwards. It's the other way around. Yeah, vertical lines, my green line, are undefined. My pink line, left and right, is 0. You guys on board? Point slope form is super useful because when you are given a point and a slope, this is the one that you're going to use. When you're given a point and a slope, you use that. Now, let me tell you about all these parts here, okay? The y1 and the x1, those right there, those represent your point. Whatever point that you've been given, it'll always be in the form of x1, comma, y1. So those right there represent the point. What does m represent? Obviously the slope. Yep, sure does. You guys got it. That's your slope. Okay. And what about these other two? What about this y here and this x over here? What do we do with that? Those are your variables. You leave them alone. Okay? You don't touch those at all. You leave those alone because remember, you're only given one point and one slope. So we have to plug in 1 point and 1 slope. So there's the dissection, the diagram of that particular form. All right, here's an example for point slope form. Notice that you're given a point. That's that one there. There's your point. And you're given a slope. That's your slope, right? So given a point and a slope, we're going to use point slope form. So we're going to plug in. We're going to say, all right, well, y minus y1 equals m x minus x1. So this is the x, this is the y, and that's my point. So I'm going to say y plus 1 is now equal to a slope of -2, and then I have an x minus 5. Why is it y plus 1? Who sees it? Times negative, right? Now, shut up, Marina. So, okay, good. Now I have point slope form. Okay, how do I graph it then? How do I go from here and graph it? Okay, yeah, you can actually go on to slope-intercept form from here. So moving on to slope-intercept form, we just continue with the algebra, right? It'd be y plus 1 is negative 2x plus 10. Everybody see that? Then what do? Subtract 1. So what do I get? Negative 2x what? Plus 9. Good. How do we graph that line right there? Good. Let's go ahead and graph it, okay? So review of graphing. If we're going to do negative 2x plus 9, 9 is our y-intercept. Go up to 9. And then what do I do from point 9? Anybody? Shout it out. Yell it. Yeah, drop down 2 and then go over 1. Good. Once you have those 2 points, you only need 2 points to draw a line. Of course, you would use a straight edge because it makes it look way nicer than what I just did right there. Okay, slope-intercept form. What is it? What's this one? Yeah, the most famous of them all, right? Y equals mx plus the b. You guys got it. What's the m stand for? Of course. Easy. That's your slope. What's the b for? Y-intercept. We just did an example of one like this, right? That's your y-intercept. And pretty simple. We did this one. Okay, so let's do a quick example because I'm feeling that you're on board with this. So what if we did f of x is equal to negative 2/3 x plus 5. Wait, how come I just switched it to f of x? Why did we do that? Same thing, right? That's called function notation. Function notation is allowed. They're interchangeable, right? This is a linear function, right? Which means it's a function of a line. Very good. Absolutely. We're not trying to trick you here in math, right? We give it to you straightforward. Okay. If we're going to graph negative 2/3 x plus 5, what does the negative 2/3 represent? That's my slope. And then what does my 5 represent? That's my y-intercept. Okay, go ahead and graph that. You guys go up to 5, right? Okay, you go up to 5. And then from 5, what do? Down to 1, 2 over what? 1, 2, 3. Right? And then your line would look like this. That represents negative 2/3 x plus 5. Okay, I have a little basic equation up there. It's called x equals 5. Okay? Hands up if you think that is a linear function. Hands up if you think it's linear. Let the record show only half the room thinks linear? Yep. Okay, hands up if you think it's not a linear function. Hands up if you have no idea what that is. Okay, fair enough. It is a linear function. I'll give you that one. It's a line. But the question is this a vertical line or a horizontal line? Horizontal? Is that both put together? Okay, a horizontal and vertical. So when I graph this, hands up for horizontal line. Hands up for vertical line. Okay, let's see if you guys are right. So this is a vertical line. Yes, you guys did great. Okay, let's compare that to y equals 5. Yeah, I wish you guys could. Okay, which one's this one going to be? Horizontal or vertical? Let's just see if you guys are right. Yep, you're right. There it is right there. It's that blue one. Okay, why is this the case? Why is this the case? So let's do this. Let's talk about these, okay? Copy this, put this over here. Alright, why is my blue one, why is that the equation y equals 5? So we'll write that down. This one is y equals 5, and then the red one was what? X equals 5. Okay, that's supposed to be clear. So now, how do you tell that? Most students mess this up, okay? Why would they mess this up? Because you think the x line should be in line with the x-axis, but here's the question you ask yourself. See the red line? What axis does it go through? It goes through the x-axis, so therefore it must be an x equals line. What about that blue line? What line does it go through? What axis does it go through? The y, so it must be a y line, okay? You can also take a bunch of test points, and every single x will be a 5 in that red line, and every single y will be a 5 in that blue line. You can do it as well. So, in general, horizontal lines are in the form of y equals some kind of a. Vertical lines are in the form of x equals some kind of a, and a can be a variable moving around. Okay? Okay, general form, also known as standard form. Okay? Why would anybody ever use this? What is this good for? Nothing. No, it's good for something. It's good for, yeah, I forgot my eye. Quick sketches. Okay. Okay, it's good for very, very quick sketches. Let me give you a perfect example of why somebody would use this, okay? Okay, 3x plus 4y plus 12 equals 0. First of all, it's a line. It's a linear function, right? Second of all, it's in general form or standard form, okay? So, when you graph an equation and you look at the x and the y intercepts, what's special about those points, the x and the y intercepts? What is special about these points right here? Can you guys give me something like what's special about that point and what's special about this point? They are the intercepts, right? So let's talk about this one, the y-intercept. It would be, this one be 0, comma, y. You guys agree with that? Okay, what would this one be over here? This would be x, comma, 0. So what's special about them? Are you noticing? Yeah. It's the point on the graph where the other one is 0. So like the y-intercept, the x value is 0. The x-intercept, the y value is 0. Okay, so here's what we're going to do. So for these, let's just let y equals 0. If I let y equals 0, here's what I'm left with. I get 3x is now equal to negative 12. What did I do? Yeah, because if you put 0 in for y, it cancels the whole term out, right? So then I brought 12 to the other side, so then what? Divide by 3, divide by 3, so x must be what? So check it out. Now I have a point, don't I? Negative 4, comma 0 is guaranteed to be on that graph. Do you see that? Ah, very cool, okay. What's the second thing I'm going to do? I need another point. There you go. Let x equal to 0. I love it. If x is 0, here's what I get. 4y is equal to negative 12. So therefore, y must be what? Negative 3. So what point corresponds to this now? 0, comma, negative 3. There you go. In about 4 seconds, we quickly figured out 2 points that are guaranteed to be on the graph. So once I have those 2 points, I can now make a quick sketch, can't I? So this is very useful. Awesome. So let's go ahead and make that sketch. Yeah, that's why standard form is useful, right? So negative 4, 0. 1, 2, 3, 4. That point's on there. And 0, negative 3. 1, 2, 3. That point is on there. So therefore, my graph is looking something like that. And I did not need to convert it to y equals mx plus b or anything else. I didn't even have to find the slope, right? So general form is kind of nice. Okay, you try on your own. I want you to find the intercepts and give me a graph of 4x minus 3y minus 6 equals 0. Okay, so you should have got the x-intercept was what? 3 halves, comma 0 or 1.5. And what's the y-intercept? 0, negative 2. Awesome. Very good. Nice job, you guys.